Cool. So I'm here to talk about service mesh. Is there anybody in the audience that's like service mesh curious? All right, great. Yeah, a couple of you. Just out of curiosity, for anybody who's willing to offer up, is there a reason why, like, was there a reason preventing you from taking action on service mesh to this point? Or was it just, I've just heard about it recently and, you know, kind of want to get involved in it? Yeah?
I mean, just to answer something.
Yeah.
I know my colleague is, we're starting to use Istio.
Okay.
My colleague is doing, we're going to be using it for TLS, like service-to-service authentication. That's
Okay.
a very use case for us. But
Cool.
I don't think much has been preventing us from doing it.
Okay, fair enough. Yeah. So we see a lot of customers that are like really interested in service mesh, and the thing that's been preventing them is basically the complexity and some of the cost associated with running sidecars. So we're going to talk about how you can run it lean and mean, and you can scale way up. So this was a talk that was originally proposed by Christian Posta. So sorry, I'm not Christian Posta. But if you'd like to talk more about service mesh, I will be here later this afternoon. So Ambient has been around for about a year. What we're going to talk about today is moving Ambient into multi-cluster and making that a reality. The fact is that most companies don't want to adopt it right away, like as soon as something comes out, right? It's a little risky to be the first one out there to market. So hopefully this will allay your fears, and you'll be more comfortable with jumping in all the way. So just a little bit about how this works, right? How is it different from a sidecar-based model? Essentially, you know, we still want to handle all the traffic for all your pods so that we can insert things like security, observability, you know, very important. Obviously, traffic management is key there. The way we do this is we separate it into two separate proxies. Most people are in your camp where we want to institute MTLS across all our services by default, right? We just want to make that part of the infrastructure. So that's what the Z tunnel is there for. So it does layer 3, layer 4. We'll check the identity of all the services and the service traffic, and you can actually, you know, put authorization policies in your mesh with only a Z tunnel as a daemon set, and you're good to go with MTLS. It will also provide you, you know, the typical observability that you're used to seeing. So if you want to do traces and logging and find out, you know, when critical applications are not performing correctly because they're not responding well, this will still give you that. Now, if you have any kind of more advanced L7 requirements, things like being able to say, you know, service B call service A, but it can only call GET requests, then you're going to need to inject a waypoint proxy, which is an Envoy-based proxy. So this is what you would traditionally do in a sidecar-based model, but now it's independently deployed from your application, so you can scale it up and down as needed without having to worry about, you know, scaling waypoints along with your application. So what does this look like, you know, in terms of deployment? The Z tunnel, that tiny Z that you see at the bottom there, is intercepting all traffic from the pod namespace. So, you know, even if you're sending traffic from one pod to another on the same node, that is encrypted, and it's enforced. So you don't have to worry about that, even if, you know, obviously if you're going from node to node, you're going to be going through the Z tunnel for that traffic, and so all that traffic is going to be encrypted. Now, of course, if you want to deploy your waypoint, that can be deployed on any node. You can use taints and tolerations if you'd like, you know, to assign them to particular nodes, scale them up and down. Typically, you have to scale up and down your your application more than you would Envoy. It's quite performant. Like I said before, it is kind of a leap of faith to be the first ones out there to try this out, but what I want to tell you now is that you won't be the first. There are lots of companies that are on their path to production currently, some with insane amounts of scale, right? We have customers that are in tens of thousands of applications, clusters with 1,500 nodes or more, and hundreds to thousands of clusters. So if your scale is larger than that, I would be shocked, but just know that you won't be the first. Now let's talk a little bit about multi-cluster. There's a little bit of an eye chart, so I apologize for that. This is taken directly from the Istio documentation. But what this shows you is essentially how discovery works across multiple clusters. If you want to share pod information as pods come in and out, as nodes comes in and out of your cluster, and discover all those applications that you need to route to, you have to share that information somehow. The way that that's done in sidecar-based Istio is that you share the API server from each of your Kubernetes clusters across cluster boundaries. So basically you get all the information that you would get that IstioD needs in order to configure multi-cluster. That's a lot of information. And it's also kind of a security issue, right? You're now sharing keys across N squared, right? Probably not what you want to do. So when we analyzed this and looked at it, we thought, okay, now that we've got Ambient, we have sort of a separation of concerns here between L4 and L7. We can optimize for this particular scenario here and share the information that really needs to be shared. As I said before, your waypoint is a traditional Envoy proxy. The zTunnel is not. It was rewritten specifically for this purpose. So we took advantage of that to share just the information that you need to know about where your pods live, how to reach them if you're federating your applications across clusters. So it's very lightweight discovery information that we're now passing across. So what this allows us to do is obviously scale up quite a bit. So if things like, let's say you have outages, IstioD goes down, it's not really a concern there. We'll still be able to find that information. Now, I'm hurrying a little bit because I want to actually get to the meaty part of this, which is how we scaled and how we test. So this chart is showing you in the green bar here our test platform where we ramp up the number of clusters we're adding in that we need to share in discovery. In the sidecar-based mode, what you can see here is that by the time we get to 10 clusters, we're already hitting boundaries. Our nodes here are basically, at 16 limit, 16 CPU limit. And so we hit that, right? And by the time we hit that 10th cluster, we're kind of out of resources. Meanwhile, the orange line at the bottom is ambient mode. And you can see it has almost no effect on the performance there. Now we went ahead and decided to see where the limits were, right? Let's just keep adding clusters and adding clusters and try to find that out. There was a ramp up period where we added a lot, and that's where you see that spike, but as soon as it kind of went through the discovery, through that rush of information, it calmed down and leveled out to a consistent, very low volume into something that would fit in a very, very small cluster. Right? So now, of course, there are potentially operational challenges that you might face. Multi-cluster, I'm going to save that till after the talk. I'm going to speed back this a little bit, but I do want to point you to this blog post that John Howard wrote, where he talks about some of the mechanics of how they do the testing and some of the scale that we went to. We did have to virtualize part of it just because if we actually created the environment that we hit the limits on, or we didn't even hit the limits on, it would have been like $1 billion a month cost, so we obviously couldn't do that, right? But please take a look at that. I think I'm out of time, but if you want to talk to me, I'll be around. Thank you.